In a previous video, I got an idea for how to evolve the design of RLCI to support a database. In this video, I show you how I got started. Why does RLCI need a database? RLCI is a continuous integration system, and currently it only has one hard-coded pipeline, and when running it, the logs are just printed to the console. With a database, we can store multiple pipelines in RLCI, and we can also store the logs of the runs in the database so that we can present a history of the pipeline runs. Having all the information in a database also is more flexible when it comes to presenting the data about the pipelines. Here's how I got started working on this. So first of all, to make sure that we don't break anything, let's run the tests in loop so we can get feedback on test failures. There we go. And now we're going to try to extract this hard-coded pipeline into some kind of structure instead that can be stored in a document like database. So I'm thinking that we can start by having the database just as a value up here, and what we have here is a stage. So what is a stage? Let's call this one stage instead. And a stage has a bunch of steps. Let's call them steps. And the first step is this step right here. So how do we encode a step? Just like a command. Sure, let's say a step is a command. Just like that. Okay. And now what we can do down here is to say for step in stage steps workspace run step and a command, and this should still work, and it does. So let's move the next one as well. So this will not work, but if we include it here, it works again. Let's move the next one as well. The next one is a little bit different because here we're using the slurp function. We can encode that up here as something like this. So we still have the command, but we have a variable parameter as well, and in this case it's called version. Yeah. And in that case, we want to do slurp instead. So if step get variable none, maybe we can just do that. If it's not none, or rather if it is none, then we do this. Otherwise we do this. Step.get and step command. That works. But we don't want to hard code the variable here, so we need to introduce a a dictionary for those, so variables, empty dictionary, and then variables, stage variable, store it in there as well, and then down here we have to access it in variables version. No. What went wrong? We're not doing deploy at all. Let's back up a moment. Let's just... That works. And can we also do variables step variable is version? That works. And now we should be able to replace this one. Yeah, and now we should be able to do this. Yeah, I'm not sure what went wrong the last time. So sometimes I find it easier to just revert to the last working point and then redo it in smaller steps instead of trying to figure out what the error was. So the last part here that we have in the pipeline is still a command, but part of the command is a variable access. So how can we encode that up here? So let's see. So this is still something command. So what are we going to write here? Oops. So what we're doing here is we're converting the Python code here, which is the hard-coded pipeline, into some kind of language for representing commands and how they interact with each other. And in a representation that can be stored in like a document database. And this part right here is turning into an interpreter for this language. And in this case, we need a way to say in this language that we want to read a variable that we have previously stored. So one way we could do this is to say that this part right here is not a string but a variable and version. And we can see here that we're expecting I'm not sure if we can see that. Oh, we're duplicating this line here. So what I wanted to see was, yeah, we expected like a version, but we get this hash instead. Never mind. Maybe we get some other kind of error. And for this to work, we need to transform the command. So let's just do it like this. Command is, so maybe we should revert like that again, so we have a passing test. So I'm thinking here that the command is x for x in step command. So replace this one and this one. So that still works. And here we're going to do x if is instance x string. So otherwise we will look up the variable. So this is saying if x is a string, then we return that. So for every item in this command, if it's a string, we just return it. Otherwise, we assume it's this variable, and we'll look it up like that. So that should still work. If we run this one, it should fail because we have this one as well. So let's remove that one and see what happens. Yeah, it works. So now we have extracted the RLCI pipeline to a data structure which can be stored in some kind of document database. And this part right here is just an interpreter for this data structure. And this data structure now represents a stage in a pipeline. In the future, a pipeline will contain multiple stages that connect in various ways, but at the moment, a pipeline is only one stage. So let's see if we can introduce like a database interface and see if we can get this code out of this class and into somewhere else. So let's somewhere introduce database class, and for now we needed to support save pipeline. That's the data structure that we extracted below. And for now we can just save it off like this. And get pipeline. Something like that. And up here we can say self.db, it's new db, self.db.save pipeline. And the pipeline is this. Yes. And down here, instead of stage, we do self.db.get pipeline. Does that work? Yes. That's how I got started. With small incremental refactorings, I slowly started to extract a database class. After this, I continued to flesh out the database class, and I ran into a problem of trying to figure out what the structure of the data should be. And I realized that that depends on who is going to consume the data. And currently there are no consumers of the database. I had two stories in mind when I started working on this database extraction. And the first one was to support multiple pipelines, and the second was to store logs for pipelines to present like a history of pipeline runs. In evolutionary design, we only design as much as we need to be able to implement the next story. But now with this database extraction, I had designed it with two potential stories in mind, none of which I had committed to. So I had speculated what the database needed to be. What I should have done was chosen one of the stories to begin with, and then only evolved the database as much as that story needed, and then moved on to the next one. I think I will revert the speculative changes and start over. I'll be back next week with something else. Bye.